Welcome back to the course on Advanced Switchgear. Today we are going to see about theories of circuit interruption. The phenomena of arc extinction is very complicated. It is explained by a number of theories. There are two important theories describe how arc is being extinguished. First one is Sleplan's theory. Second is Cassie's theory. First we will see about Sleplan's theory. Arc extinction process is a race between the dielectric strength and restriking voltage. If the restriking voltage is very higher and the dielectric strength of the medium which is present in between the contacts of the circuit breaker is low, then the arc will initiate and it will restrike again. After current zero, there exists a residual column of ionized gases. When the current waveform goes to zero position, then there will be no arc current. So at this time, the arc will be extincted automatically. So after the extinction of arc, there will be a residual column of ionized gas which is present in the medium. This medium is present in between the two contacts of the circuit breaker. If the dielectric strength builds up rapidly so that it is greater than the restriking voltage, the arc does not restrike. In current zero, the arc will be extinguished. We know that. At this time, if the dielectric strength of the medium builds up very rapidly, so it is in such a way that the dielectric strength of the medium is greater than the restriking voltage, then the arc will not restrike back. If the dielectric strength build up is slow so that it is lesser than the restriking voltage, the arc will restrike. If the dielectric medium in between it has lesser dielectric strength than the restriking voltage, then the arc will restrike back again after current zero. This is the graph showing kilovolt in y-axis and time in x-axis. You can see the dielectric strength of the medium is very high. In this graph is shown, and in the B graph you see the restriking voltage, and this graph again shows the dielectric strength of the medium. If the dielectric strength of contacts is more than the restriking voltage as shown by curve A above curve B, then the arc will get extinguished. From the curve A and curve B, we can see that the dielectric strength of the medium is very high than the restriking voltage, so the arc get extinguished very easily. If the dielectric strength of contact is lesser than the restriking voltage as shown by curve C below curve B, then the arc will not get extinguished. Will not get extinguished. You can see on comparing curve B and C, curve B restriking voltage is higher than the dielectric strength of the medium. So in this position the arc will restrike back. Sleplan was first to point out that the restriking voltage plays an important role in arc extinction. Now we are going to see some disadvantages and inconsistency in Sleplan's theory. First one is it assumes that restriking voltage and buildup of dielectric strength are comparable quantities. Slepians take an assumption that restriking voltage and dielectric strength are comparable quantities, but the assumption is not correct. These two entities are not identical. He is not assuming that voltage is equal to voltage. No, he is not like that. He is assuming restriking voltage with dielectric strength of the medium. These two quantities differ and are not identical. So his assumption is not correct. After that, the theory does not consider the energy relations in the arc extinction process. He did not give any mathematical equation as energy relationships. Theory does not cover arcing phase, hence it is incomplete. We know arcing phase is after the current zero, what is going to happen is known as arcing phase. So Slepians did not give any concept of about arcing phase, so his theory is incomplete and does not cover the complete relationship from the beginning of the arc to the extinction of the arc. So we move towards to the next theory, which is Cassie's theory or energy balance theory. The following assumptions are made in his energy balance theory are: arc consists of cylindrical column at a substantial uniform temperature over its cross section with well-defined boundary. He says that the arc present in between the two electrodes has a cylindrical column, and this cylindrical column will have a uniform temperature over its cross section, as well as the uniform cylindrical column will have a well defined boundary. It will look like a cylinder. That is, the arc will look like a cylinder and it will have a uniform temperature all over the arc, and the cross section of the arc is also uniform. The second assumption is there is a uniform distribution of energy in this column. He also says the distribution of energy in the arc is also uniform. The third assumption says the volume of energy density is constant for the complete column of arc. So the energy densities in the column are also constants, and the temperature remains constant. The cross section of arc adjusts itself to accommodate the arc current. The fifth point is noted as the cross section of arc adjusts itself to accommodate the arc current. If the arc current is high, then the cross section of the arc is also high. If the arc current is low, then the cross section of the arc is also low. So the arc will accommodate itself to the arc current. Power dissipation is proportional to the area of cross sectional of the arc column. If you take a cross section of an arc column, the power dissipation will be proportional to the area of arc column. These are all the assumptions made in energy balance theory or Cassie's theory. Energy equation of arc equal to dq by dt equal to ei minus n. Here dq by dt is the energy content or the charge content in the arc with respect to time. Q is equal to energy content per centimeter of arc length with respect to time. Okay. E is equal to volt per centimeter and I equal to total current. N equal to total power loss per centimeter. This is the energy equation of the arc formed by Cassie's theory. Conclusion. Cases conclude that the breakdown of dielectrics occurs only if power feed in the arc is more than power loss. If the arc is interrupted, if the contact plates are feeding the power into the arc through these ionized gases and the arc power loss is more, then the breakdown of the arc is difficult. If the power feed in the arc is low and the power loss in the arc is high, that is the ionized gases are not present in the medium, then the breakdown of the medium is very difficult and the arc will get extinguished. There is also another theory known as Mayer theory. This is also similar to Cassie's theory but with different assumptions. Mayer's theory does not cover post-arc phase, hence it is incomplete. So now we have studied about Sleplan's theory and the other one is Cassie's theory. These two theories forms the main theories of circuit interruption. Next we are coming to the conclusion of this unit. Aspects and considerations to be followed in circuit breaker to extinguish arc. Arc extinction can be obtained at current zero by building dielectric strength. We now know that at current zero, if the in-between medium has very higher dielectric strength, then at once the arc will get extincted. Otherwise, the arc will get restrike. Dielectric strength should build up rapidly and by dissipating the energy feed into the arc. We know the current zero position will going to occur in a very fraction of milliseconds. So during that fraction of second or fraction of millisecond, the dielectric strength should build up rapidly. Otherwise the ionized particles will be present in the medium and it will again cause the arc to restrike. So we should choose a material in such a way that the dielectric strength of the material is very high and it should have a capable to dissipate the energy and also to recombine faster so that the arc should be prevented from restriking. Arc extinction process in circuit breaker is influenced by several aspects such as speed of contact, material of contact, pattern or flow of quenching medium, The speed of contact gives the speed of separation of two contacts, and the material of contact, the second point, gives you which type of material is used in the contact plates of the circuit breaker. If you use copper, it has a different characteristics. If you use carbon, then it will behave as a different characteristics. So the material of contact is also important. The third point is the pattern of flow of quenching medium. The flow of gas into the medium so as to remove the ionized particle from the medium. The magnitude of arc current and variation of arc diameter. The magnitude of current you are going to interrupt. If you are going to interrupt a low value of current, or you are going to interrupt a high value of current. Energy liberated during the arc. Rate of rise of transient recovery voltage. Rate of gain of dielectric strength. How fast the medium you are using going to gain its dielectric strength back. These are all the factors going to influence the extinction process of arc in a circuit breaker. Arc extinction process can be considered in three different zones: arcing zone, current zero zone, post arc zone. These are the three zones where the arc extinction process has to be carefully maintained, and in each zones you have to do the necessary steps, or you need to design the circuit breaker in a correct manner. Arcing zone, the thermal stresses produced by the arc are predominant. So in the arcing zone, we need to take care of the thermal stresses. If the thermal stress becomes very high, then the entire circuit breaker will get damaged. Every circuit breaker, an attempt is made to reduce the arc diameter by using various techniques. So the various techniques are lengthening of arc, splitting of arc, and cooling of arc. In arcing zone, we will employ these three techniques to predominantly reduce the thermal stress. Then we are coming to current zero zone. In current zero zone, it gives a transition where the arc will be cut off by its own nature. The next is post arc zone. The voltage stress becomes predominant because after the zero current, the current starts to rise again. So in this time, the voltage stress will be more predominant. So the ionized gases present in the medium should be removed in the post arc zone. In circuit breaker, attempt is made to introduce fresh dielectric medium between contact space after final current zero. So in the circuit breaker should attempt to introduce a fresh dielectric medium. Okay, after current zero, the circuit breaker should introduce fresh dielectric medium in between the contact space so that to remove the ionized gases from the medium. The dielectric material chosen should have a very high dielectric strength, and it should have a good regain property. It should get recombine faster than any other dielectric medium. Thank you.